In this video, we're going to continue our discussion of Taylor and Maclaurin series. We're given the function f of x is equal to cosine of 2x squared minus 1 divided by x squared. We're asked to find the 10th derivative of f of x at x equals 0. Now, we can certainly differentiate this function 10 times using the quotient rule and the chain rule, but that would be very difficult and time consuming. So we're going to apply Maclaurin series to find the 10th derivative at 0. So basically we're doing a shortcut for finding the 10th derivative evaluated at 0. The hint we're given is use the series for cosine x as a building block for developing the Maclaurin series for f of x. So let's start with the Maclaurin series for cosine x. Cosine x is equal to 1 minus x squared is all the even powers of x divided by 2 factorial plus x to the power of 4 divided by 4 factorial minus x to the power of 6 divided by 6 factorial plus x to the power of 8 divided by 8 factorial. Now let's plug in 2x squared for x. Plug in 2x squared for x. So now we can get the Maclaurin series of cosine of 2x squared. Our goal, of course, is to develop the Maclaurin series for f of x, which is cosine of 2x squared minus 1 divided by x squared. So plugging 2x squared for x, we get 1 minus. Now we have to do this very carefully because 2x squared is going to be placed inside x. So we get 2x squared all squared divided by 2 factorial plus, and here we have x to the 4th, so we're going to get 2x squared. We plug in 2x squared for x to the power of 4 divided by 4 factorial minus 2x squared to the power of 6 divided by 6 factorial plus 2x squared to the power of 8 divided by 8 factorial, and so on. All right, so we have the Maclaurin series of cosine of 2x squared. This is equal to 1 minus 2x squared all squared divided by 2 factorial plus 2x squared to the power of 4 divided by 4 factorial minus 2x squared to the power of 6 divided by 6 factorial plus 2x squared to the power of 8 divided by 8 factorial, and so on. Now, our goal is to find the Maclaurin series for this function. F of x is equal to cosine of 2x squared minus 1 divided by x squared. So let's subtract 1 from both sides and divide by x squared. So we have cosine of 2x squared minus 1 divide by x squared. So we have to subtract 1 from the numerator, so we can simply do that like this, 1 minus 1, and then rewrite the rest, minus 2x squared to the power of 2 divided by 2 factorial plus 2x squared to the power of 4 divided by 4 factorial minus 2x squared to the power of 6 divided by 6 factorial plus 2x squared to the power of 8 divided by 8 factorial, and so on. All divided by x squared. So again, we subtracted 1 from both sides and divided by x squared so that we could get the Maclaurin series of f of x. All right, so let's do some algebra. 1 minus 1, this cancels out. We're going to get, in the numerator, we're going to get minus, and let's simplify this a bit. We get minus 2 squared x to the power of 4 divided by 2 factorial plus 2 to the power of 4 x to the power of 8 divided by 4 factorial minus 2 to the power of 6 x to the power of 12 divided by 6 factorial plus 2 to the power of 8 x to the power of 16 divided by 8 factorial minus plus and so on, all divided by x squared. Now let's factor out x squared from the numerator. So if we factor out x squared from the numerator, we get x squared times minus 2 squared x to the power of 2 divided by 2 factorial plus 2 to the power of 4 x to the power of 6 divided by 4 factorial minus 2 to the power of 6 x to the power of 10 divided by 6 factorial plus 2 to the power of 8 x to the power of 14 divided by 8 factorial, all divided by x squared. Now, because we factored out x squared from the numerator, we can cancel x squared from the numerator and denominator. And we now have a simplified version of the Maclaurin series of cosine of 2x squared minus 1 divided by x squared. That's all of this. All right, so now we have basically developed the Maclaurin series for f of x, but we're looking for the 10th derivative evaluated as 0. So we're just going to match up the term involving x to the power of 10 with the 10th general term of the Maclaurin series for f of x. So let's do that. We have basically, we've got cos of 2x squared minus 1 divided by x squared. This is equal to minus 2 squared x to the power of 2 divided by 2 factorial plus 2 to the power of 4 x to the power of 6 divided by 4 factorial minus 2 to the power of 6 x to the power of 10 divided by 6 factorial plus 2 to the power of 8 x to the power of 14 divided by 8 factorial, and so on. Now, we're interested in the 10th derivative evaluated at 0. So what we're going to do is we're going to look at the general term of the Maclaurin series that involves x to the power of 10 and match it up with the term that involves x to the power of 10 in this series, which is this term here. So the general term of the Maclaurin series is going to be f10 of 0. This is the 10th term of the Maclaurin series, x to the power of 10 divided by 10 factorial. And this is very important. Match this up with this term in our series that involves x to the power of 10, and then we basically solve for f10 of 0, the 10th derivative evaluated at 0. So we force these to be equal to each other. Minus 2 to the power of 6, x to the power of 10, divided by 6 factorial. Now we can easily cancel out x to the power of 10, and we can solve for the 10th derivative evaluated at 0. We get f10 of 0 is equal to minus 2 to the 6 divided by 6 factorial, and multiply both sides by 10 factorial. We get 10 factorial on the right-hand side, and there it is. This is a 10th derivative of the function evaluated at 0. So again, the key concept was to match up the term that has x to the 10 in it with, so basically this is the 10th term of the Maclaurin series divided by 10 factorial. This is the 10th general term of a Maclaurin series that involves x to the power of 10. Make it equal to the term that we have here that involves x to the power of 10. Minus 2 to the power of 6, x to the power of 10, divided by 6 factorial. And after that, it's just algebra. Cancel out x to the 10, and multiply both sides by 10 factorial. Multiply by 10 factorial. This cancels out. And we solve for the 10th derivative at 0. And that gives us all of this. Minus 2 to the power of 6 times 10 factorial divided by 6 factorial. All right, thanks.